doesn't appear. Well, okay, no, I'll change the...
It's okay, it's nice to see your tutorials. Okay.
So many tutorials. So, okay, can you hear me well?
Yeah, perfect.
After term 2, we started, we focused more on the phenomena of the water as material. We started trying to articulate a couple of scenarios and different strategies for water-based architecture and urbanism. And so what if water could be related to an urbanism which is like in an intrinsic way related to all the phase changes, and human activities are classified according to their relationship with each phase, and could be related to each phase, are classified as exothermic or endothermic reactions. So this is a scenario, like we can quickly go through this because I don't know which is the best way to present all this work, because it's not, it's like a bit fragmentary. So we could try to suggest a self-sustained way of living by different zones of activities and minimum water urbanism related to water infrastructure, in a way that each phase of water establishes an event which is related to a human activity like cooking, bathing, fishing, hydroponics, or fresh water. So we started doing some different simulations regarding phase change. Another strategy was about a tissue strategy, where we could extract the mechanical properties of water, emphasizing more on freezing and evaporation. So in a way that we use freezing as expansion that actuates a growth, and evaporation as a mechanism of shrinkage and making the material stiffer and more porous, we could say.
And also we looked into other strategies from nature, like for example, the Biro desert has this texture that is like scientifically called hydrophilic and hydrophobic. And we made simple sketches of how we would, get inspired how these, from nature, the systems of harnessing water through collecting water through the fogs, for example, from air. And on the left, it's just a simple sketch of how the texture of the system for material, for example, would be having bumps where these bumps actually attract water because of the surface tension. And for example, we also imagined how the same texture, the same material would not only harness water, but also store, function as a storage also. And then next slide also, this is strategies other people have used based on texture, materials. The same idea that surface tension of the water attracts it. And then the next is another sketch, which is rainwater collection. We were imagining how it's a simple sketch of how a material can be like a balloon, that would fill up with water that has no shape, no geometry, but actually it expands and contracts during brain collection. And then this is another strategy where we looked into getting water desalination, actually, from the sea, and how we could use the salt after evaporation of the water, and how we could use the salt as a layer into the material that can attach to it and performs a certain function.
As we saw in the previous term, we focused on creating a phase change model, focusing more on the micro scale and articulating a rule set that could express water phase change property. Now we want to be able to relate that to to the water cycle, and to create an energy cycle, which could mean a self-sustained system, addressing like how water is adaptive and how water can nourish, basically. So in this term, we focused after term 2 work, we focused more on working into the digital material concept, and we tried to see how we could create a gradient material from using water properties, using water as a base. So this is like a concept of how water across the phases changes its properties as a gradient. So we could advocate that it's more flexible when it's liquid, and rigid when it's solid, while it's more elastic when it's liquid again, or the volume, which becomes bigger when it becomes solid, or it shrinks when gas evaporates. So we tried to, through this circle, to create, to understand a material that could have, could approximate different properties. So it's either more rigid and opaque and more dense, or I don't know, a different combination of properties. So we looked at the history of, into the history of functionally graded materials, which is...
So basically, like in a short, briefly, we can discuss how other people were looking into gradient materials. Basically, it is two materials, and they would mix up in a graded zone. There are two stages, basically. The one is creation of a spatial heterogeneous structure, and the second would be the consolidation. The first stage, the gradients obtained with the constitutive homogenizing and segregation methods, and the second stage would be by obtained by drying, sintering, or solidification. So multi-material has its advantages, and there are mainly 5 advantages. One is that we can customize structural rigidity. 2, we can create variable material responses to structure, to environment, and the aesthetic. 3, we could revolutionize the design process itself. 4, it is cost-effective, it is efficient, it basically bypasses the procurement process, it bypasses the coordination between other disciplines during the construction. So, and through one singular secretion of variably continuous multi-material. And then the 5th is like to reinstitute the architect's role of actually like taking back full responsibility from design to construction in architecture, basically, by through the process of fusing techniques. These are a few examples. Other people have been exploring multi-material Costas. He explored how he can fuse aluminum and glass for his project on mullion, and mixed matters, synthesis design. They did a chair, they 3D printed it using a gradient 3D printing technique, and Mary Oxman looked into, her project was about varying 44 materials in a chaise-longue, basically, that each material was affecting the sound absorption.
A multi-material would also mean could also mean a change of paradigm in the way that we perceive space and environment. So we could draw this analogy in the way that from the MRI scanning, it is commonly used to depict now the different substances. Basically, it shows the distribution of substances in the body. So we can see the difference of representation of body as a mechanism, or with different parts that get connected with joints, to another example of understanding the body as a continuous layer of changing substances. So these are some MRI representations also. And it also challenges the way that we understand boundaries and boundary representation, since MRI is a voxel-based technology. So there is no BDEP, there's no boundary representation. These are some MRI representations of fluids where we can see this difference in density and substances very clearly and interesting. So the main idea that we would like to emphasize is space as manipulating and varying locally material properties, and how we can use it and engage with that.
So basically, this is a workflow we're taking from a digital to physical aspect. So as Daphne was saying, that we were looking into how to the gradient of water as a material, and gradiate it and becomes a multi-material. And in the next slides are the simulations. We were trying to simulate water as a material, but before introducing temperature and with different forces linked to the particles. This is other patterning that we found during the simulations. So the strategy in simulating, maybe next slide. The strategy in simulating these particles, we used something called the spatial bindings. Basically, they can be similar to voxels. They are containers, and each container has a number of particles, and within these containers, the particles interact, and from one container to the other, the particles also interact with each other. So we use these bins as our container to input temperature maps into it, the temperature bitmaps, and the container would read this bitmap and transmit it to its agents. And basically, the colors of the bitmap indicates the temperature and different temperatures. And with these different temperatures, there are different behaviors of phase change. Sorry. We can fast forward anything.
Is that okay? Should we?
Yeah, let's move. And this is another simulation. So we just want to like make clear, because we've been building up the code in Unity, and at this point we're in the last stage of, like, we introduce the bitmap into the container or the bins, and at this point we are just tweaking the values of the forces within, so that they actually show phase change. They show the different gradient material throughout the population. But hopefully by tomorrow we would have them.
Yeah, so this is again a bit incomplete. Yeah, that took quite a long time to optimize. Should we skip them?
Yeah.
So yeah, a little bit more about the materiality. We started looking to hydrogels. Hydrogels is a material with are biodegradable polymers, are 90% of water, and their basic properties are that they can they can influence shape, they can vary its properties according to different mixtures. When these mixtures are tuned effectively, they are biocompatible and biodegradable. They can store water, they can store substances, and they are hydrophilic. So again, we could imagine a gradient of hydrogel, like varying its properties according to toughness or softness, porosity or density, elasticity or stiffness, and high viscosity or low viscosity. A very commonly referred paradigm about like organic materials that are that are gradient is the squid's beak, which it follows very much this idea. It's one of the hardest materials found in nature, and actually is the gradient goes from towards the tip of the beak. It's 100 times stiffer than the other side of the beak. So through this variation of substances like protein, dark pigment, heating, and water, the properties also change, like softness, elasticity, and stiffness. And yeah, so we also explored some different fabrication methods that could work with hydrogels, and or some custom-made methods. Yeah. Next part is how we relate. We try to see how we could work with environment data and the object data. So, data that we take from the environment are those that could relate us to phenomena, and object data could make us could create a relationship to object properties. To different functions, for example. So we mainly work with different types of fields, like scalar fields. We explore different types of fields, trying to influence our simulations. So scalar fields are mainly good scalar fields or vector fields. Like scalar fields could be temperature, pressure, and sound value, like from the environment. And vector fields could be gravity, flow, current fields, air currents, or magnetic fields, or then some normal, tangent, and gradient fields when we talk about object data. So these are different types of fields. And here we try to implement to show how we could affect our material properties from these fields, how we could influence. So using a temperature map, which is a scalar field oriented to the temperature of human, we could influence different different distribution across the different temperatures, let's say, of the body. So we could manage also to distribute different materialities potentially with different temperature conductivity. And here we could use normals, vector field, to orient different, to orient again a distribution. So here, for example, we use scalar temperature field to influence our distribution in the place that it's more it's hotter, and we use also normals to direct the advection and the growth. So we could say that this is the hydrated, while this is the stiffer and the dehydrated example. And the same works here with different pattern distributed, and again with different textures, studying how directionality plays a role. Going from the stiffer to the more elastic one. Then we try to explore how curvature, which is the amount, like how steep is a curve of an object, but we couldn't find, we didn't manage to finish that part. But this is how a growth could be driven by curvature. And then a gradient field, which shows like the extreme points, the gradient ascent or gradient descent. We could use, for example, these extreme points to vary our material stiffness in the extreme points, let's say, or to direct a flow, which could start from the points that are the extremes in the. So that's all from us. It's a bit fragmentary, but we were in between testing different ideas and we didn't manage to really fix them together. I don't know.
Yeah.
And then we could see other studies of vector fields and environments and how this could be transferred to a material again. That's all from us.
Okay, you had a couple of slides that just flicked up, which had some text slides that basically was organizing things. Yeah.
This now they're more older.
Okay. I mean, I would say this. I mean, I quite like the fact that you guys are exploring different techniques and trying to explore different kind of methods to explore some of this work. And I wouldn't I mean, I wouldn't overly stress in terms of trying to make everything somehow fit within a narrative right now, because I think that there are probably some fundamental things that we need to discuss. I mean, we spoke about the concept of multimateriality, I think primarily because I think there was a desire, or it seemed like it was a latent desire to think about phase changing also as something that was inevitably an empowering and an enabling thing in your project, to think about water going from also the capacity to be this kind of rigid, amazingly powerful, dense material to something that is completely fluid and transformable. And I think your definition of multimateriality will have to expand, let's say, the conventions of 3D printing, because in some sense, some of the properties or the behaviors have to do with phase change, right? So for example, like when they do oil fracking and things like that, and all of this other kind of stuff, water is an amazingly powerful source where they utilize the expansion of phase changing to really like break apart some of the densest stone and other things. There's an amazing force that's a byproduct of phase changing. And I think water itself as a material it needs to be primary in the way that we're exploring this. So I quite like some of the Houdini experiments and some of the Unity work, because in some ways it's kind of lending itself for us to actually think about how we can explore water as a kind of discrete element. So a certain kind of volumetric container that potentially we can consider how that particle, or however you're using these kind of spheres as proxy objects or so forth, can be considered as a material that can go through expansion and contraction, but it's not like an inflation strategy like, let's say, the air team is doing. So I feel like there's this kind of more, I don't want to call it anarchic, I just think like exploratory way of working with different simulation strategies, I think is the right way to kind of put stuff out there and to try to kind of problematize this. The only reason I'm mentioning that is if I look at, let's say, the slide of multimateriality that includes Kostas, Neri, and Alvin, for example, all actually AA people, 2 of them DRL. Our concept would have to push, the fact that in some sense, most of these projects, if not all of them at some level, is really talking about 2 materials and the process of deposition to basically place material, and not really speaking to the performative aspects that would lend itself to. In some ways, Kostas maybe is mostly connected to that world because he was looking at it as a building system strategy, and some of that stuff was problematized with like soft kill strategies for building components and things like that. But the reason that I'm mentioning that is that some of the things that you guys are putting on the table somehow begs the question of, beyond process, what is our architecture really motivated by? Like we talked about this kind of thought experiment of thinking about like how we can move material, like a massive quantity of material, almost by thinking about, using atmosphere and phase change as something primary. So for example, like if you needed to migrate, thousands and thousands of gallons of water, there's the brute force version of that, which is what happens in the world, which is really put it in a container and move it using all kinds of other energy sources. Or for example, if we could control the clouds, you can imagine an architecture that shape shifts from atmosphere to something potentially as rigid as an igloo or a iceberg kind of architecture, right? And so the question is like, where do we want to push let's say, the goal of the kind of underlying questions that we're looking at? So the water harvesting elements, I think, is very powerful, because in some sense that's the source of life, right? In many, many different ways. So if we can harness water, we can use that to grow plants. If we can harness water, we can drink from that. If we can harness water, we can also form different ways of powering things, depending on scale and so forth. So I think that's very important. So my general comments in terms of the project, I mean, I quite like the way that you guys have been working on things. I think the diagram sketches that you guys speak to, I think the diagramming techniques that you guys use, I think is very useful in some ways, but sometimes it masks the complexity of stuff. So for example, in your document up till now, it was really used as a tool to really demonstrate information. When we use those same techniques, for example, of like rigidness for, you know, how a beetle may extract water, or, you know, desert reptiles and so forth, it starts to kind of cloud the notion of sketch versus diagram. So I quite like it in terms of a form of representation, but I think it's not lending itself in those examples to some clarity about where it's going. So they do look like sketches for an architecture, but I would explain it slightly differently, right? It's not about the representation. It's almost like a kind of underlying goal of how we go from, example in this case, gas to liquid. And so then the question that follows immediately from that is like, okay, what is that beyond, let's say, phase change in terms of scenario? Like, how do we see the carrier of the things? Like I sent you guys like an example of a edible basically water bottle kind of thing. The reasons why I find some of those things kind of interesting is kind of like hydrogel. It basically becomes a material that has different kinds of properties, right? It's, when it's a gel, it's somewhere in between, you know, ice and water. And it has this kind of viscosity that actually lends itself to other properties. All of those properties probably have contingencies that we could potentially utilize in architecture, but I think we have to somehow give some priority to what's the main driver. So if the main driver is moving material, atmosphere is very important, and then the product of its materialization, right? So for example, if we had to design, let's say, a controlled deposition strategy in your world, if we had to just invent it, it would be almost like we have no bounding box, there's no container. We would utilize, you know, these kind of cloud formations, and the clouds would be our printing machines that would deposit things in different areas. Do you understand what I mean? Like if we had to challenge the convention of things, it would suggest that the cloud is actually the printer. You know, the material that is fed into that printer is actually the atmosphere in some sense. And then the translation of what is printed to what is solidified would be an act of basically phase changing from something that is, you know, gas to liquid into something that's solid on the other side, which is like whatever is the outcome of our printing strategy, that is actually dealing with material contingencies, which are closer to the viscous and solid state. So, I mean, I don't know, excuse me, if that resonates with you guys or not. When I look at even the studies of the Houdini, you know, statue with a kind of applied wearable architecture in some sense, you know, the way that it's related to that based on temperature and all of these things. I know that it's just a study, but there is an implication of porosity. There's an implication of symbiotic relationship between things. I'm not sure how literal we should take that or not, if I'm honest, because I'm not sure.
Also, sorry.
No, go ahead, Daphne.
The implication on that could be something that I didn't mention, that it's hydrated or less hydrated, it's also a phase change thing, right? So it could be, we could say that it carries water and it carries substances when it's hydrated, and it is stiff and it's more like a scaffold when it's dehydrated, and more porous. I don't know how we could finally use that exactly.
Well, I mean, hydration in some sense is an evaluation of, you know, don't want to go back to this idea of sustaining life, but hydration is obviously a very important way of measuring, you know, basically if we're going to survive or not. So, I mean, like water in some senses is one of those elements that has to remain within a certain balance, right? For example, if you overhydrate somebody, you can kill them. If you underhydrate someone, you kill them. It's like this kind of direct relationship with life is a very powerful one. So, for example, I think in terms of strands of research, I like the notion of extraction that you guys are having in terms of harvesting. But also, for example, when we talk about hydration, for example, on the human body, we perspire to cool, but basically we're releasing water. You know, if there was a way of capturing that and recycling that, you know, you can imagine a kind of biofeedback to that. I'm not saying like designing new fashion, but I'm just suggesting like as soon as, like in the heat team, we see the body as a source of heat, it changes the concept of the simulation between the body and the environment. It kind of abstracts it in a certain way. When you guys are doing the simulations in terms of the spatial binning and so forth, what we consider those bins, you know, at the moment it's a kind of abstract system in terms of kind of being able to kind of deal with temperature difference. On the other hand, though, you can imagine like a bin can be a human too, right? It would have, you know, the way that we would see that field strategy right now, how we interpret that, I think is very important in terms of, is this the architecture that we're deploying? Is this the architecture plus environment? Is it something that's self-motivated and self-controlled, more like a conditioning system, or is it really something where there is very little boundary between outside, inside, between, let's say, body, space? It's a question of also like in what context. If it's in the gaseous context, that makes total sense. If it's in the solid context, those delineations become much more extreme, right? In terms of not traditional, but they become much more finite in terms of what's printed, what's not. So I think when I look at some of the implications of the textiles, what I think is apparent is the necessity for having this kind of breathability latent within the way that we would deposit, or the way that we even would think about potentially printing processes. So if you could imagine, for example, printing lattice textiles, I think that that would be closer to, let's say, printing solid cast elements, like, let's say, what you guys are showing in some of the reference models, from the perspective of harvesting or harnessing, right? So it's in terms of like, what do we see this technology latent in the architecture as? So let's say, for example, in the previous team, we talked about the fact that implications of mobility are very much a part of potentially how they can think about the notion of using air in that context, because in some ways they're using it as a translation of wind, and wind equates to electricity, and electricity can be used in very different ways. But the premise is a tethered architecture. In your case, I mean, we should take a position about how far we want to push the phase changing aspect. Like, do we really want to control the clouds? Do we really want to see that as a new idea of printing? Or let's call it additive. strategies, because it's not really additive manufacturing, right? And I think that that's where I think we have to be a little bit careful. Like, so for example, the KUKA experiment. I think if the KUKA is an experiment to speak about controlled deposition, I think that that makes total sense. If the KUKA experiment is a demonstration of functionally graded printing strategies as, like, let's say, a process like printing concrete or anything else, in a literal sense, it will have very different implications to the project. So I think that that's something that we should kind of keep in mind a little bit. Where do you guys see this at the moment?
We also, I think the good example, the good case, what we want is to be able to combine in a way the world of phenomena with the world of probably a part of 3D printing, additive manufacturing. So it could, if that could work in a way that it's combinatory. So I think that would be the best idea, because maybe we can't fully, I don't know, we couldn't fully structure around clouds. I'm not sure. I just found it very hard to structure the whole experiment around cloud deposition of matter. And
I mean, the reason that I mention it is a little bit more like, if I look at your research, like if I looked at just this presentation, I think the conversation would be very different. Right? Seeing this in the context of everything that you guys did in term 2, even with the concept of settlements and this idea of like a kind of ecology of how architecture has more symbiotic relationships. For example, water extraction in the desert, the textile strategies makes a lot of sense, right? Capturing it from the air. But for example, if you're on water or if you're by a water source, desalination strategies and making some sense of using salt and potentially what kind of additive strategies could be from that, and also having a byproduct of drinkable water, is an interesting way of seeing two different material properties, but being extracted from a water source and being redeployed in a different kind of material manifestation. The reasons that I say that is, like, not everything has to be water. That's why I think we talked about multimateriality. But water, in some sense, I think has to be conceptualized in different ways, because I think that that's really what binds, let's say, the sustaining life argument in the work. So you guys have had a quite expansive search space for that, and I think you've brought some interesting models, and that's where I think the implications of urbanism were there in some sense, meaning like the concept of thinking about life as not something discrete between an idea of space and the body, for example. It was really about this kind of self-sustaining relationship between things, and seeing that as something that goes beyond the production element of it. So the cloud conversation, at least in this case for me, is not so much about clouds in the same way, like, let's say, the previous team was talking about clouds. In this case, it's more about just suggesting that is really about less about the clouds literally, but more about thinking about how do you move material and utilize the concept of phase changing in its different forms. Like water in this case probably has its most radical kind of phase changing of all of the kind of elemental elements, because in some sense of its kind of radical place of going from completely rigid crystalline to completely gaseous, particle. The point is, do we want to maintain all of those elements equally, or what are we privileging in terms of how we think about architecture? So one of the things is how material gets to a place. The other part is actually what constitutes place. So, you know, if we're talking about additive strategies of making, what are we actually, for example, printing? What is it that we're going to call architecture in a more traditional sense of kind of space making? And I think that there has to be some goal from our side to suggest that either this is a concept of a project which is about creating a new kind of infrastructure, which is like if you create the infrastructure, then those other elements can naturally kind of grow from that. Or it's really about a fusion between architecture and infrastructure to create something like in the previous conversations that kind of destabilizes that relationship by kind of embedding those kind of elements within the kind of architectural response. So in the past, you know, there have been projects that have been printing with water, like printing with super cool water, for example, which has a very easy way of making the translation, not easy, but it doesn't take much to think about that instantaneous transformation between liquid to solid, because the super cool temperature gives a condition where that could allow you to literally print with ice in the same way that you would print with other kind of, you know, liquid or viscous materials. And, you know, those kind of projects happened in very extreme environments and happened under very particular researches, which was really just looking at that as the possibility of generating architecture, like an ice hotel, basically, in terms of its formation. So are there things that you guys are gravitating in your conversations more to in terms of scenarios?
Like you just talked about the extreme environments, for example. And when we think about ice, for example, we're thinking of printing ice and what context are we gonna speak about? Like, where would it be? And when we speak about phase change, we're including the three different states, which need to have three different temperatures, three different contexts.
Sure. I think that's, go ahead, sorry, Deb.
Sure. No, I think that ice is the most difficult to handle, not difficult, I mean, it's the one that we want to avoid, because we do not want to, ice exists in a temperature that humans do not. So hydrogels are a very good example of somehow substituting this solid phase of water, which has can work as an invisible structure, but it's not in a very low temperature that humans can't. Yeah, so I think that the concept of phase change could be more oriented to how we can harvest water from the atmosphere, how we can use water possibly for water as an infrastructure for humans, and how we can use also water as a barrier of substances, which is, I think, is also important, because it's mainly the way that water exists in nature is by carrying other substances, or by, I'm sorry, this is my car, or by building with other substances together. So if we could extract that.
Yeah, let's put it this way. I'm totally happy with whatever you guys are choosing. I guess my point is that at the moment, the presentation is not making that legible, right? So for example, it's treating all phase changes equally, and in your diagrams as well, it's not privileging a certain element to it. And I think at this stage, I think that that's fine. But as you guys are talking about it now, in terms of the possibilities of what that is, I mean, hydrogel is an interesting material in some sense. It has also problems in terms of like hydrogel doesn't release. It's not an instantaneous thing. I think it's a proxy object for certain aspects of water retention and expansion and things that we can simulate and somehow use as a seed to kind of push further. I think the concepts of what it is that we would be, let's say, printing. If you print hydrogel, for example, you can very easily think about how those print scaffolds could swell when it actually has water, or it can disappear when it's not. Even some of the experiments that you're doing with the kind of field flow strategies and so forth, they do potentially have latent strategies of how one could start to develop surface or volumetric strategies to control water in terms of flow rates of water, even in terms of ridging patterns. It's things like that you guys were talking about in terms of beetles and other things. There are ways of thinking about that stuff, and there have been projects in the DRL that basically were trying to develop kind of performative surface strategies in terms of, you know, almost like a guttering system, thinking about how valleys can channel water into different locations for storage and things like that. So there are ways of thinking about those things, and prototypically, I don't think that that's a bad thing to start with as one strand of research, which is about, you know, your system is not a holistic system that's trying to do all of these things. Your system is trying to be really instrumental in terms of extracting and harvesting water in its different forms. So, for example, rainwater, well, how would your system actually opportunize and capture that? You know, how would it actually extract water just from air? How would it do those things, I think, is important. And, you know, the difference between a surface and a volume kind of sponge strategy also speaks to orientation, and it speaks to a lot of the things that you guys already mentioned in some of your studies. So I think it's important to potentially do that. I gave you guys some examples when I presented this brief to begin with, like, for example, the rain room. You know, the rain room is obviously just a controller of nozzles, which are basically releasing water droplets, right? You know, and there are other examples of that stuff. Carlo Ratti tried to use it as a printer where he would just drop droplets, and basically you could write using water and stuff like that. So there is something about developing a kind of control system for the release of water or for the deposition of material that I think is useful. And I think we can start to think about how we can start to control some of that. The hydrogel work, I think, is obviously a water retention system and a water release, slow release kind of context. All of these things explicitly don't say architecture yet, right? Don't say space. So those are things that we have to kind of invent. But the attitude towards that architecture, I think, is important. Do we want to generate a very performative concept of an architecture which is maybe like premised particularly by just separating itself from a traditional kind of pipeline of water or electrical grid, so that you can understand that the architecture itself could be deployed anywhere, and then it can create place wherever that context actually is. That's in line of the kind of performative architectural worlds, but it becomes quite explicit in terms of what survival means and how it harnesses and how it can develop, let's say, settlement strategies and others. Do you see that as where you guys want to go with that, or do you want to push it in more speculative places?
Like speculative as in how?
So, for example, in this scenario that I just played, I mean, the question of this is a house or this or that would build and push to an extreme, let's say, how we think about technologies and infrastructure. But in terms of the actual deliverable, it would be in conversation with some of the settlements that you guys have used, maybe questioning the location if it's on land or water, or but it would be very clear in terms of what the objective is. It's a self-sufficient strategy of thinking about how water is primary to the kind of ecosystem of life and how that can somehow be the seed for generating an urbanism or an architecture that is really prototypical, but somehow is pushing, let's say, boundaries of even like kind of vernacular architectures and things forward. This is quite clear brief in that sense. You know, a different thing is to suggest like a bit more speculative is the kind of scenarios that we were talking about of trying to maximize phenomena in a way that maybe is not so tied to those technologies, but is really trying to push the boundaries of what and how materials are moved and what phase changing really means for that. Like, questions would be much more logistical in some sense, in terms of like prefacing the idea that those materials are on site wherever site is. And the strategy is really about the extraction and materialization. I mean, it's not so much tied to architecture in a sense that can be evaluated, let's say, from a history of, you know, additive manufacturing or a history of prefabrication of systems that are deployable. It would be really about challenging the notion of place and on-site and extracting a strategy that is really premised with harvesting and materialization. Much, much more prototypical, let's say. In some sense, much riskier, which I don't think is a bad thing, to be honest, at all. But it challenges the way that you're working. So, for example, right now, you guys are telling me that this presentation obviously isn't synthesized in one goal right now. The goal, like in some of the other projects, would sometimes maybe just really a research trajectory in terms of a certain declaration of what the prototype actually is trying to do. And then you basically throw everything at it in terms of trying to find a way processes that somehow make that manifest. So in some way, it would be much more in continuing this way that you guys are working, but trying to find opportunities, for example, between the digital and the analog, and trying to find opportunities about what harvesting and extraction can be, and trying to set up experiments in some ways that are slowly building up those kind of experiments that can come together in some way. But the process is very different. I don't want to say it's disjointed, it's just not linear. It's really premising like, okay, harvesting is our research and we're going to find different ways of doing that, active and passively, and somehow using that as a strategy. And then saying, okay, now you've harvested that stuff in parallel, like what do you do with it? So, you know, half of the team would just be looking at harvesting, and the other half of the team would actually be saying like, okay, we have this harvested material. How do we use that as a strategy for deposition? And really the premise of all of that stuff is that if you have those two processes, you generate a prototypical concept of a process of fabrication strategy and a survival strategy as an inherent byproduct of that. The other one is much more like a declaration of a kind of extreme environment, if it's more water-based, like you saw last year, or if it's something that's extreme, it's a declaration of a phase change, and is really trying to push that as much as possible to be able to be evaluated as architecture in a traditional sense, but with a bias towards a much more primitive, elemental, and let's call it also sustainable way of thinking about things. So the objectives are both, you know, not only meaningful, but they're just addressed in a very different way. And it's not explicit one or the other. It's a gradated thing, literally in this case, but I just think like the way that we would express it would be differently. you don't need to fully take that decision now, but I think as we're developing this, I think it's very important. So like already we talked about the idea of ice literally is not a material, if I understood correctly. It's a process which is in the context of the things that you're doing, but it's not, let's say, the primary kind of materialization because it has a temperature dependency which is quite limited in scope. Would that be fair assessment?
Yeah.
And I think those decisions are fine, and those decisions will be happening as you're exploring stuff, right? So when I look at the simulations, I think it's a really good start. When you guys are showing me stuff like the Chilton or Chitin and biomaterials and so forth. I mean, Neri, for example, in a lot of the stuff that her lab is working on these days, I mean, they will just take that one element and say like, okay, how do I use crab shells as a material to print with? And basically they'll come up with, like a latex surface version using those kind of printing processes. And so you see these kind of like dragonfly surfaces. At the end of the day, that's not architecture. That's not even a materialization of a prototype in the tradition of kind of architectural declarations of how you would use it. But it's a process of materialization, and it's quite clear about its resources and how that would be translated into a process. Your project, I think, has the possibility of moving into either one of these camps, but how we would work on it is different, I would suggest, because it would bias one thing a little bit more than the others.
I feel that this part is more to this direction of studying, like very much focusing on the material and how we distribute the properties on that. While the particle strategy could be more there is, I think, a certain decision that we could take, like water is something that simply exists, and we just use it as an infrastructure. We use it as a carrier, or we use it as to nourish and as a source of fresh water, or either water is also a structural element, or both of them.
Yeah, I mean, I think you can imagine, like, so for example, if we took the subject, I mean, the examples that you guys presented, particularly Ulla when she was presenting, and the presentation of these different kinds of settlements, there's a long-standing history of utilizing water as an infrastructure, living on water, developing strategies around that. But as soon as you introduce concept of desalination, you realize that opens up a hugely different problem, right? So for example, if you told me that your studio project was just about desalination, you can imagine that that's the guiding framework, and all the processes, regardless of how you worked on it, would be somehow motivated by that. We have a lot of salt water. How do you change that into something that's living? How do you can extract whatever that processes gives you as materials to create, infrastructures, buildings, sediment, whatever you want. So it frames the project by actually looking at it very specifically, like what's the problem? Well, the problem's response could be that. Now that's just one aspect of it. And I don't think it's not like the project would be about desalination solely, but it's really the primary contribution that you would do for that in some sense, right? Like, what do you do with the salt? Is that the material that you print with? If so, what's the use case scenarios? Is it mixed with other things? What do you do with the water? How do you contain that? But you can understand that it sits somewhere between very on-site strategy for thinking about things, which I think all of the studio needs to respond to, because on-site in our case is really about the environment and our relationship to that. These are decisions that you don't need to take like today, or tomorrow, let's say, but I think that there are things that we need to start working towards. So for example, I could be very clear and say, like, I'm more than happy to take term 3 and just work 100% prototypically, which in some sense is what I'm asking every team to do. And we can take the summer to think about the implementation scenarios and all of those things that would really form a thesis. But that doesn't mean that we don't start asking the questions now, because, for example, like in the scenario that I just said about desalination, it's a word that you guys used, but it could drive a lot. Now, if you say hydrogel and desalination, I mean, that creates a different conversation. So, for example, hydrogel is a water retention system. It's not necessarily a harvesting system, right? Could be used, but it's not extracting it by itself. It just can retain it. Could I hybridize a system between, let's say, salt binded kind of materiality and implementation of hydrogels the same way, let's say, because this is printing with aluminum and glass? Could you guys print in this kind of multi-material way? You know, if I was trying to find a way of printing with salt, I could use a proxy material like sodium acetate, which is usually like the things that people use for heating pads. It's usually something that it has a little metal element to it, and it clicks, and it basically changes something from a fluid into a solid mass with a kind of chemical release of heat. And that's why they use this kind of heat pads and things like that. And then if I want to reuse it, I boil it again and then do it again. There are different ways of thinking about these things. So for example, you can print hydrogel, or you can be printing the salt, or you can be printing whatever. It's more about the control of material, right? And the release of material. So I'm cool with all of it. Honestly, I just would like you guys to think about what you think is the most meaningful contribution to it. I think that that's the powerful part, is for you guys to, as you're continuing to develop these kind of simulations, start to work, let's say, in a multi-material way, which means that we interpret material as behavior in my studio. Does that make sense to you guys? Like, my approach to all of these things, conceptually, philosophically, theoretically, whatever you want to call it, is that everything can be understood through behavior. So instead of simulating literally explicitly material expansion and contraction by itself, we are really looking at the processes between those behaviors. So for example, you know, you have different expansion coefficients, even in like Costas's thing, like by printing aluminum and glass, expansion, contraction of certain metals, expansion or contraction of glass are different. So you can gradate them, but realistically speaking, you could also sabotage its integrity if, for example, the temperature changes, or for example, the temperature in your architecture that has water retention, the difference between a container that's filled with water and a container that then transforms into ice is that that container is going to expand by however much of a percent, 3 to 5%, whatever it is. That container won't be existing anymore, because the phase change would basically undermine the concept of the container in that sense. So I think these are kinds of things that you guys can consider in some way. I like the idea that you continue to push the simulations. I just think that we should frame them slightly in terms of how we look at it. And then best case scenario is to be able to mine some of these experiments and to think how we output them in some way. So for example, even communicating to a KUKA is first, could be a step in terms of like tangible translation in terms of a deposition strategy. But I also think, like, for example, you could be printing with hydrogels and thinking of it as a placement of objects instead of a printing of like squirting material. So there are conversations about what those things are and at the same time, right? Have you bought some hydrogels and just see what it does? They're pretty cool when they're filled with water, but you realize that they're also very fragile and brittle, and they can break very easily. And so it's a way of actually thinking about those things as well, right? So for example, by themselves, hydrogel are very vulnerable. So are they in a container or a net or some other ways that help to organize that? Is that part of the process, for example, of what extraction can be? Like one example could be like if we had textiles that had embedded hydrogels within it, can we extract and retain? How would we deploy that at the same thing? So for example, some of those examples of water capturing devices that are textile oriented, if there was hydrogel packets embedded within that, you can imagine the process of that also changing its shape and its formation and its scaffolding logic. So as those things are extracted, they're also retained in the system, or they're migrated somewhere else and retained somewhere else. But you can understand just by a simple decision of that, it sets up a particular research about how material is deployed and where, and how some of that expansion also introduces other variables. Like obviously water has weight, and you can go from something that is completely a light textile in the wind into something that's soaked and very heavy, or something that changes into hydrogels, which beads up, and you can imagine them breaking off the surface and rolling themselves somewhere else. I mean, there could be very different concepts of release and what impregnating these fabrics with different behaviors could be. And you can start to think about those strategies from a very specific prototype and simulation, right? But that's just one element. That's just really looking at one aspect of a proto detail of something. Somebody else could be looking at larger organizations. I like the fact that you guys all have perplexed looks on your face. That means that you're thinking through all of these things, and nothing is clear, and you're hating yourself for being in my studio, but also love it at the same time. So that love-hate affair, I think, will continue. But I think, realistically speaking, I want you guys to just be looking for opportunities. Like when I look at the MRI scan, strategy stuff, it starts to become a little bit more representational in terms of like the way that you guys were describing that. It became very narrative, right? Which is slightly different from how some of the other things were being discussed. So the sum of those things are kind of work in progress, right? Because very clearly somebody can look at that and say, oh, it's about the body, it's about this. It lends itself to many interpretations. So careful with those things, basically, is what I'm suggesting. We don't want to limit abstraction or limit literalness. We don't want to shy away from putting some ideas on the table of what the architecture can be. So like the heat team placing basically that those figures with those particles swarming around it, in some sense, is a kind of provocation for possibility. I'm not suggesting you do that because it's a different project completely. But I am suggesting that if you really think that this world is hydrogel, then honestly, we should start to see it for what it is, which is much more transparent. It's got a certain material quality to it. It would have certain relationships to how we see it in those different stages. Like its functional gradation would also be about the volume of water that it's retaining at a moment in time. And if that's uniform or if that's controlled in a different way, right? And I think that those things are really important. I've played around a lot with hydrogel, and I think it's a super interesting kind of tool to stimulate some ideas about things. For example, like if you have a lot of water, they disappear, so you don't see them. Even if you have these kind of discrete kind of spheres, you only recognize them when you start to shift the water around. That invisible, visible, all of those kind of elements we're talking about. On the other hand, the salt-like elements, I mean, have a very different world to it, right? Like stalactites or these kind of salt caves and things like that. It has a very different notion of deposition because it's not static. The material itself over time, regardless of its deposition, will start to fuse, will start to almost like melt away. So it has also a different concept. That could be a scaffold, it could be other things. Does that make sense?
Yeah.
Are you guys okay? Or you guys need some therapy, design therapy? You guys are doing well. You guys have a lot of stuff on the table, and I like the way that you're working on things. The Unity work is starting to move into a place where it's not generic, which I think is very positive. So the binning strategy, I think, is a very good way to start to work on things. But I would also say that that needs to be pushed a little bit into things that are not just representing difference. And I think some of the suggestions of some of the Houdini work, I think, is also interesting to see how some of that stuff can be embedded, let's call it, into prototypes that are changing. So the setup is the same, but what's changing is the amount of extraction of water or other things. And if that's responding to the body in terms of hydration or other things or not, I think that's something that you guys can be exploring at different scales. The hydrogels don't necessarily scale in the same way that other things scale, right? So I think that that's also an interesting thing too. So I'm not really sure how big a hydrogel pellet you can actually get, but you can imagine, like, at some moment in time, you know, do you want to live in that space? Do you want to see that materiality? Is this really about a translucent, transparent architecture? Could I pick these things almost like I would be picking grapes outside of my grandmother's house, and, you know, have a function of edibleness, where the architecture itself is a living thing, you know, something that also can very directly sustain and nourish somebody. You know, these are the kinds of things that potentially could be looked at in some way, right?
I think that in the case of hydrogel, it shouldn't be the only material for sure. So
Right.
we didn't talk only for a transparent architecture, but
I think that that's true. And I think I gave you guys an example of just like hybridizing the textiles with the hydrogels. And in some way now, depending on how you do that, if that's surface, if that's lattice, I think that gives you a way of maybe taking some of the Houdini experiments and starting to test it, right? And you can imagine that that's not necessarily all of that either. Like, I'm sure there are more elements to the architecture, but it's a study in its own. And it's clear where the harvesting and the retention aspect are somehow being discussed. And I think as long as you can conceptualize some of the things in a certain way, you can explore them in really varied ways and still have everybody understand what you guys are doing, right? My only point about the material presence is, like, it's not about if I really want a completely transparent architecture or translucent architecture. It's what does the material kind of offer me? And then the question is, like, how do I deploy that for two very different and competing elements? One is harvesting, and the other one is, like, now this is part of my architecture. So the criteria is not just storing it somewhere like storage, it's also about living with that stuff. And how does that become part of the idea of what this living architecture will be? So those decisions, basically all I'm saying, have implications. And what's important in terms of this studio is always seeing that whatever you do potentially has two different ways of utilizing that action. That's generally how we work on things. So we usually don't design just A to B. It's usually like If we have A, we have choice A1, A2, A3. If we go into B, we have choices B1, B2, B3. So combinatorially, A1, B2 means something. A3, B5 means something, let's say. And those kind of things are kind of important in terms of what we mean by system. Like our systems are considered as frameworks. So that means that they have the possibility to be more than a thing. Now, the question about what they can be is really dictated by you guys. But I mean, that's usually the goal. And that's where we usually have adaptive characteristics embedded, because it's not really complete total design. It leaves a degree of uncertainty so that it can be reappropriated by the system itself. It's never fully optimized, because that would make an assumption that there is a certain volume of water. Of course, that may be what's a normal kind of cycle of, let's say, the environment, but realistically speaking, those change, and our architecture is designed for that uncertainty and change. Anyway, I think tomorrow will be interesting. Just put the things together to somehow put some of the questions that you guys are thinking as something primary. Okay, let's take the position that this is being designed as something prototypical, and our position on sustaining life is about utilizing and harvesting water, but also using that as an instrumentalized multi-material process. So that multimateriality may include conditions like desalination, so forth, so forth. So these are the material contingencies of those materials. And we're trying to find a way of hybridizing that. So the difference between a multi-material process and a multi-material architecture is the concept of performativity would have very different scales and relationships. So that's very different from the multi-material examples that you guys gave. And in terms of printing, the one thing that you can look, I mean, I don't usually speak about Skylar Tibbets very much because of certain, let's call it past things. But the one thing that is, I think, interesting is the fact that they've been looking at printing in viscous materials, which basically means printing in gel, which is not rocket science, but it's basically using gel or a water-based kind of gel as really the container, which I think is interesting. That means that the deposition of the material can be suspended in some way. So, I mean, we've tried in the past, like printing into water, especially with soft metals and other kinds of things in the studio. So basically like deposition of aluminum or other things. So the water was really like a form of explosive formwork. But I think when you start to deal with more viscous materials, that material presence is very different. So using the kind of logic of water-soluble material, I think is something interesting. Now they're just basically using it as a printing volume, but I think the implications of using it in this way, I think, are interesting. So it's like printing in Jell-O, basically, or hair gel, stuff like that. So you can have a look at that stuff. Is that okay?
Yeah.
All right, guys. I mean, I think this stuff is super exciting. I don't know how you guys feel, but I think it's going to force you also to have to organize your work in a way that is much more design research oriented, to be able to be kind of clear of the thematics, even if the experiments are very divergent. So those declarations, I think, are important. But I like the I like the diagramming and the degree of synthesis. I think it's quite useful. I do think that your team has the implications of urbanism, so I would want to suggest that that doesn't disappear, because I think honestly, when you think beyond the actual materialization of something, there are other processes in architecture and in settlement and urbanism that are very important. And I think that you guys are capable of working on that as well. So I just keep that there just to make sure that we don't dismiss it completely, because I think that there's an important aspect to thinking about how this architecture actually becomes much more ecological and symbiotic, not just in its materialization, but it's in its really sustaining life, literally. So beyond building, basically.
Do you think that we should keep also this for tomorrow, these scenarios, which are not so relevant now?
I mean, I think the issue of if they're relevant or not, it's up to you how you want to discuss them. So I'm not so against keeping what you have here. It's more about how you talk about it, because I think that opens up the conversation, and I would potentially reorganize a little bit of it. Like, for example, water harvesting, hydrogels. I think water retention, even exploring ideas of deposition and all of these other things are just things that are interesting to speak to in a way that's somehow constructing that bigger discussion. So I don't think the way that you presented today was bad. I think it was good. I just think that there were also a lot of other aspects that are not talked about at all. You're not going to touch on all of them, but I think I would suggest that there are maybe, the first 5 minutes just kind of brings back a little bit of that initial elemental stuff and the decisions of what you've taken. So, and then focus on 10 minutes of what you guys presented today. Is that okay? I mean, this is really like a progress meeting, so it's primarily focused on let's call it progress. But in terms of our studio, it's very different, because I didn't basically give you, this is your brief, this is your program, and these are the tools that you're using. So we have a slightly different, well, let's say a radically different demand in the studio, that you have to really design the brief and the response. So in some ways it's much more demanding on you guys, and that's why I probably spend a lot more time like in this kind of conversation mode with you, because we have to talk a little bit about implications, and we have to talk about things beyond what's on the page right now. And for example, like the KUKA experiment, I think it's very useful, but it's not really about robots, right? In that sense, at this stage, it's really about introducing control of material and deposition. And at some point in time, it will be a conversation. Well, are we literally using a KUKA, or are we using something else? I would say we're not using a KUKA at all. Like, I would fully declare that from now, because that would imply something very different, and all of the desire of the studio to make something more phenomena driven and elemental and on-site would be somehow undermined by using big, large, heavy robots to do this work, right? So I would treat it as an experiment on deposition and control and, placement. So as long as we're working in that way and it's described in that way, I think nobody should have a misrepresentation of it. But I think we shouldn't assume that other people are just going to follow the track of thinking that we have. Does that make sense?
Hello, Theo. Sorry to interrupt you, but can we, our last group, Earth team, also have the opportunity to have this pre? We haven't prayed yet.
Yes. So let's go with you guys now.
Okay, thank you. Soon we'll show the PowerPoint.
Did you think that I forgot you?
Yeah.
No, I don't forget you guys. Come on, I love the Earth.
Thank God.
Okay, guys. All right.
Thank you, Theo.
Okay,
No.
thank you. I don't know why it's stuck and I can't stop sharing. It doesn't pop up. So I don't know if you start sharing.
Yeah, maybe you guys can.
Yeah, I'm sharing my screen.
Okay, so maybe Daphne just quit Zoom and then I'll let you back in.
Okay, thanks.
Not to be hardcore about it, but your computer seems to have a mind of its own today. Okay.